Hello and welcome to another video. Today we will be doing another two-tool Toby part, but this is the toughest part that two-tool Toby has ever put out there, in my opinion. So just to emphasize how difficult this is, I will try and keep the editing down to a minimal. I will show you all the mistakes, all the F-ups, and let's hope this video turns out to be less than an hour. Now let's go straight and take a look at this part. There are a lot of dimensions. It looks like it's very well annotated, but it's not, right? You need to be creative. You need to interpret everything correctly, and I'll start straight up telling you that this is probably one of the toughest parts. This is a tombstone shape, as it's called in two-tool Toby tournaments and explainer videos and whatnot, and it's angled, right? And what's more, if you look, it's an inch and a half down here at the base, as it's specified here, but you will see that it flares out, right? It flares out. So how do you draw this, right? Is this a loft? It could very well be a loft because it seems like the profile is changing. Well, there is this first hint here, okay? So take a look at this. This is the R, right? The radius of this arc down here is 1/2 inch. And then the radius of this arc here is also 1/2 inch. So that is a hint. What is going on is that if you can imagine it as two different bodies, right? Like when you're doing a Boolean operation, this tombstone shape has been tilted and then sunk into this floor. Okay, so this 1.5 inches is a part that's sunken further down than this back piece here, and that's why it looks like it's flaring up. In fact, this shape is a standard tombstone that's just been sunken into this floor. And how do you do that? Well, now that we've discussed the most difficult part, in my opinion, we will discuss about this. That's not an easy part either. But now that we've discussed the most difficult part, let's start designing it. Okay, so how do we start with this piece? Okay, well, we will start with this floor, right? And you've got this edge here, which is 275, 2 3/4, 2 3/8. Okay. Then you flare out, you do this arc, which is a 0.625 arc, and then you go here, another straight arc, and then you have this piece closing everything up. So this is pretty straight up to design. Just notice this. Okay, notice this. This straight edge. So at the end of this straight edge, we've got the center of this fillet, okay? That means this fillet is tangent to this edge. And what's more, this straight edge is also 2.375, so 2 3/8. So these centers, these arcs, are precisely horizontal to these points. Okay, and then everything else is tangent. And then you have this dimension here, so 5 inches from these centers. So let's go do all that. So let's start with this part. I'll start with a line, right? I'll just say that this is 2.375, right? 90 degrees, so horizontal. And you can see I can move this around, but I wanted it to be symmetric to the z-axis plane. So I'm going to use the midpoint constraint with 3 points. Now that means that the origin is always on the perpendicular bisector to this line segment, and since this is a vertical line segment on the xy plane, that achieves what I initially wanted that. So let's continue. I'll pick up a line here, Then I'll do a tangent arc. You can find it up here. You just hotkey it. So let's do that. Then we've got another straight line, another tangent arc. And then we close this up. Let's add all of the tangencies that are missing. Okay, so what do we have here? Well, first of all, we've got these two arcs being equal. As we discussed, we've got the centers being horizontal to these endpoints here. And, you know, let's also make sure that the center of this shape is also symmetric to the origin. Okay, now all that's left here is to dimension these fillets, which is 0.265 according to the print, and to give this 5-inch dimension. So this is fully defined, okay? And if I remember correctly from the print, it's 1/4 of an inch thick. Oh, yeah. So I keep making that mistake. There are a couple of bolt holes, let's say here, and we can definitely add them now. If I remember correctly, they're 1/2 inch. Let's check later. Let's go check. Yeah, they're 1/2 inch. So basically we did everything that we needed to do. Now we're going to tackle, right? Now that we've got the floor, we're going to tackle this angled tombstone. And we're going to do it in a way that I think is a nice approach. And it's one that if you were handed this piece in a competition, you would never think of on the spot unless you were really, really lucky, because it's a really, really difficult thing to come up with, right? But this is what I think is the best approach here. So, so this is the top side, okay? So I will now reference this view, right? This section view. So I have this line that's 2.875 inches from the edge of the piece right here. Okay. And then from this point starts this axis. Now there are many, many things that are going on here. First of all, this axis needs to be at 15 degrees to the floor. And this is the axis of symmetry of this hole and of this circular part of the tombstone. So basically, this tombstone is angled 15 degrees to the back, right? But this dimension here tells us where this tombstone starts, and this also tells us, for how long it keeps going. But if you look at it like this, right? Let's just stay on this section view. If you look at it from the side, this is just a rectangle, right? This is just a rectangle tilted to its side. So what I'm going to do is I'm going to make a rectangle here, right? A trapezoid or whatever, and I'm going to extrude it, mid-plane extrude it for 2.375 inches. So all the way out here. Why? Because I know that this dimension is already larger than what I need to. So, oh, sorry for that. So what I'm going to do is I'm going to extrude it up there, and then I'm going to extrude cut the tombstone shape by sketching on this plane that will be created, right? And that way I will have an edge down here which I can project. And I can mark that 1.5 inches straight on that projected line and get what I want. It's going to be a bit of a involved way to do it, so bear with me. So we've already started our sketch. So basically I want to project this and this. So starting a line, okay, 2.875, and then okay, I'm going here. I've got 4.25 of length and at 15 degrees. Okay, now I can make these two into construction lines now. And this is exactly what we have in the print down here, right? You can see it. Okay, so now I need to make this. And you can see that this shape goes beyond this line I just made. Okay, by how much? Well, this is interesting because this is the center line of this hole, right? Which is concentric to the arc here of that tombstone. And we know that the arc has a radius of half an inch. So what that means is that the difference between this axis and this top line is also half an inch. That's the radius. So let's go and design that. What I'm going to do is I'm going to go like this, which is a very rough, draft. And then I'm going to go input all of my constraints. So I just put a constant constraint there. This needs to be vertical to that. And then the distance here, the aligned distance is half an inch. And now I put all of the other verticals, and I just also need to tell it that this is 1.265, and now everything is fully defined, right? So I will extrude mid-plane for 2.375 inches, okay? Now I have a very, very rough and ugly block up here, but this is a huge win for me, and you will see why now, because this has just saved me so much trouble. Actually, I also forgot to do something, which is create an axis, a reference axis based on that line from sketch 2. We will do that later. It's not a real problem. But let's go and finish this now. So now we're sketching here, and look what I'm going to do. I'm going to spin this around, and I'm going to reference this maintaining associativity. Okay, now basically I also want to bring everything else here in. Okay, I'll just start the line and tangent arc and another line, and these two are tangent. We just put this in, and I also need to tell it that this is half an inch. I also need to tell it that this is in the center of this entire shape, and what's more, I know that this is tangent to this top edge. Why? Because I designed this initial block so that it is. Okay, and we also need to tell it that these two are equal. But what's the angle, right? What's the angle between them? Well, we don't know, but we do know that on this back side here, right? On this back side here, the distance is 1.5 inches. There you go. Everything is fully defined now. So this is a trick, right? This is the trick. You design an intermediate shape, which is this huge block, and then you create your final shape by cutting through it. Okay, so that's what I'm going to do. I'm going to cut through it, and in fact I can also input this half-inch hole that it's got in there. So what am I going to do now? Well, you see that this looks to be creating a mess. Well, no, because I will extrude cut up to geometry to the floor. Okay. What? You know what? I think that it doesn't like this. That's what I think. Okay, let's try that again. Because when I extrude cut up to here, there you go. Okay, but this gives me so so look, right? We had the circle here, but we didn't use it. So now, do I need to sketch it again? Not really, right? This is kind of like using layout sketches in Alibre, which is something you definitely can do, and I will do a video about it. So I will project this previous sketch. I will make everything a reference figure. Okay, and then I'll just click here, right click, convert to regular figures. There you go. So this is a sketch that's being controlled by whatever is in sketch 3. I will extrude cut this as well. Now I can just do to next, reverse. That should be fine. Okay. So you see this, and you can see that it still flares out, right? So this is a 1.5 inches on this side, and it's something completely weird on the other side, right? So we got the shape that we wanted. We just needed to make an intermediate geometry, which is, I know, very counterintuitive, but yeah, you know, that's what you need to do. Now, you see, I'm sketching now on the ZX plane, right? Which I intentionally made into the mirror plane of this entire shape. Okay, so I'm sketching on the ZX plane, and I just projected in this entire flank. Let's go back into the drawing here, and I'll explain to you what I'm trying to achieve here. Now we go, oh, sorry, let's highlight. So now we go into this view here. Okay, so now I'm going to make this entire sidewall profile. So I need the projection of this flank, because I need to draw this little piece. Okay, that comes in vertically to that side. Okay, you can definitely see that, I mean, maybe it should have had an angle dimension here to stress the information, but this is a competition drawing, and it tests how well you can deduce these stuff, right? That's the whole point of the competition, how well you can deduce dimensions and constraints and all that, and build your 3D model. So this comes in vertical, right? And at the end here, right? The end here, not the beginning, at the end, it's 8.75 from the floor. Okay, so that's what I'm going to do now. So I'm going to come in here, and I'm going to use a rectangle by 3 corners, right? And I'm just gonna tell it, so like so and like so. So this is 0.25. That's the width it protrudes inside. Okay, and now I can dimension this. So 8.75. Now this is fully constrained. The way I did it, I've got a geometry line here, right, which will divide my profile in two, and then I won't be able to extrude it in Alibre. So I will just hit my shortcut key and convert it to a reference figure. Alternatively, I could have right-clicked and done it here. But now let's go and sketch everything. You know, do the rough sketching of everything. So we've got those lines and a tangent arc, and then we close it off. Okay, let me project this in. So this line stops there. This and this is collinear, and we've got a perpendicular constraint going there, and then I'll just do tangent here, Is that enough? No, I also need to do a parallel between the two. Okay, now if we reference the print, okay, let's reference the print. So this circle here is a 1.25 inches circle, and it's got a 0.75 through hole on it. So let's go make that. Oh, sorry. We move and we hold shift, we move a bit, and now we've got a diameter dimension going. So that's 1.25 and then 8.75 circle on it. Okay. But look, this is not fully defined, right? And look at what the degree of freedom is that we have up here. So this is the line that we need to dimension, and this is the point where I forgot to make the axis earlier. Okay, but I'm going to leave this sketch here for now, and I'm going to go back into sketch 2, because as we can see on the print, the center, right, this center here is located precisely on that line. Okay, so what I'm going to do is I'm going to come in here and I will click here and I will click up here and I will insert, I will create an axis from that reference line. Okay, then I can come back into this sketch, right? You'll see that I have my reference axes showing, and I can just make the center here coincident to the axis. And now this is fully defined. So I will extrude this. Well, I said I wouldn't do any editing. Okay, well, yeah. So I shouldn't have done that, right? What I should have done instead, but I'll keep all of this. I will make this back into I'll make this back into a geometry line. So I'm sketching on the symmetry plane, right? So what I should have done is I should have made this. Oh yeah. I see. I also forgot. Yes. I also forgot to make this into reference geometry. We should be fine now. So what I should have done is I should have extruded this mid plane with 2.375, and then I would have had this face to sketch on that flank, which I will do now. But because I did all that sketching, I'm just going to bring it in, right? And I will simply make everything, well, everything that I need to use, I will just make it back into geometry. I also need to select a line here, make this into geometry. Let's analyze, see that I did mess up. Okay, yeah, open loop. Oh yeah. Okay, so I made this into geometry when it should have stayed as a reference. Let's analyze again. More issues. Oh, this is okay. Now we're good. So now we extrude, and we can just say minus 0.25, and then we mirror along this, and we've got most of it done. We have most of it done. We now only need to make these flares on either side of this. Okay, how do we do that? Well, by the way we designed it, we know that the distance here is 2.375. Okay, so I will sketch here. I'll just make a circle, And then I'm going to use this constraint, which does two things at the same time. Makes a couple of arcs concentric and equal at the same time with one click, right? I'll just put it there. There, it's located. I will project this in. That's the sketch I need to do. I don't need to do any more sketching. And now I need to figure out by how much I will extrude it. Well, let's reference our print. So we need to be there you go. Sorry, so we need to be 2.5 inches on the outer sides. So I am at 2.375 here, and I want to extrude it by enough so that it becomes 2.5. And then I need to extrude it the other side as well, all right? So I have another extrusion this way, and I need to extrude it by enough so that it becomes 1.5 inches. And again, let's remember that we are at 2.375 currently. So let's go in here. I'm going to make a dual depth, right? So, okay, so this is the top side and this is the bottom side. So here, I'm going to open a parenthesis. I'm going to say this is 2.5 minus 2.375. So what I want to get at minus where I'm already at, I'll divide it by 2. Then I'll go on the other side and say 2.375. The minus is implied by the fact that this is a positive number extruding towards a different direction. So I'm just going to flip the order of the numbers here. So 2.375 minus 1.5, so that I don't get a negative value and messes everything up, divided by 2. And then now I should be fine. Okay, and then I will mirror this as well. And let's go check. So here to here, 2.5, nice. And from here to here, 1.5. And this is the part where I say, isn't math fun? Well, I mean, math is fun, especially when it comes out correct. We should have done everything correctly. So let's let me remember. This should be 2.63 pounds or something. 2.64 actually. Yeah, there you go. Yeah. So 2.64 pounds, and if we look at the print, it requires a precision of 2 digits. We hover over this precision drop-down menu, and with the scroll wheel, lift this up to 2, right? You can use the scroll wheel and change this. So 2.64, which is indeed the correct answer for this part. Now, hugely difficult part, and I have to admit that first time I did it, I didn't think of this intermediate shape. This is a technique that actually Victor K used in a completely different model in last year's competition, and I think it's a huge time saver, even for real parts. You want to design a real part instead of hunting for obscure commands and doing some really advanced stuff. You just plonk down a block, an intermediate block, and you're good to go. Great technique. It makes this part a lot easier. Maybe that's why Victor K is actually the champion. And I hope you enjoyed it. I hope you liked it. If you did, please hit the like button and please subscribe, because there are more videos coming and it'll help you get the most out of Alibre. Thank you so much, and I hope I see you in the next one.